Good morning, Fancy Meat Computers. How's everybody doing today? I hope everybody is, bloody thing. Ugh. How is everybody today? I hope you guys are doing well. Hope that hasn't changed since yesterday. Still destroyed by midterms? Were you guys destroyed before the break by midterms, or are you being destroyed now? Like, when is the destruction? Is it past destruction, future destruction, or present destruction? Gotta get laced up. Before. There you go. Next to destruction is every week of November. Yeah, sorry about that. We kind of didn't have a choice. You know. Yeah, didn't have a choice, unfortunately. The calm before the storm. So, there we go. So, pursuant to some of the feedback that I was receiving about the lecture, while the lecture was going on, I fixed a few things. So I fixed the H gaps so that they are matching with the Wikipedia definition, which is you take every H element, right? So you take every sixth element starting with 0, so that's 1, 2, 3, 4, 5, sixth. So that's, well, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, etc., etc. So that should make everything a little bit easier to understand. And with the binary search procedure, yes, I noticed. I agreed with the problem with this. I also fixed assignment 2 because if you've taken a look at assignment 2, basically like the instructions for how to produce the binary search, I basically just copied this slide into the assignment, so I think it's a good slide. But yeah, so we did binary search, and we were just going to analyze it, and then we were going to get on to topic 6, pointers. Dun 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 dun. Pointers, 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 pointers. Yeah. So, binary search. So the whole business of this algorithm is you have a large number of numbers, and you reduce the search space of this large number of numbers by half at each step. So if you think about linear search in the same sorts of terms, the way that linear search works is that it starts, like, it examines one element at a time, which means that the portion of the array that you know the element isn't in grows by one element at each step. So that's what differentiates a linear time algorithm from a logarithmic time algorithm. So with this guy, the search space is divided in half each time, at least half. So this means that we consider it a big O log base 2n algorithm. This is considered a good complexity. Sometimes that's written as LG. Sometimes log base 2 is just written as log, which is particularly confusing. Whenever you are presented with a logarithm, the question you should have immediately at this level is, what is the base of this logarithm? I have seen log taken to mean like base e, like the natural logarithm, which is usually written ln, but I've seen it written as logs sometimes. LG is sometimes written like... I don't think I've seen LG as anything but base 2 at logarithm, but, you know, it's always important to ask what the base is. Because you can't just assume 10 anymore. So... this is sometimes because we're ignoring the base of the logarithm for big O reasons, or this is sometimes because when a computer scientist says logarithmic, the base 2 is implied because it's computer science. So, yeah, generally speaking, like one of the things you'll find with people who do a lot of math for a living is that they come up with their own little abbreviations and expect everybody to, oh, Allie, there's a delivery. Thank you. So, you know, one of these things that mathematicians sometimes don't feel like they should have to write is the base of the logarithm. We do not talk about November. So, if it's in a computer science context, you can kind of sometimes assume that it's just base 2. But anyway, this essentially means you can deal with 1,000 items in your array in only 10 steps. And you can deal with 1,000,000 items in your array in only 20 steps. And this is worst case runtime as well. But again, it requires that the thing be pre-sorted. So there you go. I have a small comic. Some of you may have heard of the traveling salesman problem. Brute force solution is big O n factorial. Dynamic programming algorithms are big O of n squared times 2 to the n, which is still terrible, by the way. Selling on eBay, big O1. That is constant time. So there you go. Any questions? Any questions while I load the next slide deck and get rid of the Python from the previous class in the background? Friggin' Python, man. I know. Python's not my favorite language either. So. Good. So let's talk about pointers. Oh, I need to friggin' regenerate it. What? So dumb. I mean, hey, Python wouldn't receive so much slander from me if it gave me any reason to have any respect for it whatsoever. There we go. Pointers. So, we're going to talk about pointers here. So, programming advice. Are you having trouble with your computer? Let me give you a few pointers. Oh, ouch, was that a bad pun? It was an indirect reference? I suspect these are all bad puns. Don't worry, they're the least significant bit of my speech. Ho ho! Jokes explained. Aren't pointers programming tools, T-Rex? They are. They allow one to reference the address of data instead of the data itself. It's like knowing someone's phone number lets you get in touch with them personally. Hence the delightful indirect reference pun. I too think these puns are pretty awful. Conclusion. Everyone, program harder. When a wise man points at the moon, the imbecile examines the finger. By a person a lot of quotes get attributed to. So, what the heck's a pointer and why should I care? Pointers are one of the most powerful constructs in C, nay, in programming whatsoever. A pointer is a variable whose value is a memory address. Where most variables directly reference the value stored at some position in memory, pointers are indirect references. In this set of slides, we're going to talk about pointer data types, pointer operations, and applications of pointers, as well as dynamic memory allocation, because you can only do that with pointers. Pointerization. Hey, you learned this yesterday. What class did you learn this in yesterday? Not mine, I hope. A pointer is not declared as a new data type, but is a modifier to existing data types. So one very important thing to know about pointers is that they do not carry, like, you don't declare pointer. You declare an integer pointer. Like, pointer is a modification on existing data types. In tutorial. Ah, okay. Yes, that makes sense. It was mine in a manner of speaking. Oh, well, that's okay. So, this is good. You'll have heard it. You'll have heard this a couple of times. That's good. It'll pound it into your skull jelly. By which I mean brain. So, when you create a pointer from a value, or a variable, sorry, when you create a pointer from a variable of any other data type, the way that you do that syntactically is you put the asterisk character adjacent the data type. You can actually do it adjacent the variable name as well. However, adjacent the data type is preferred. This is to say, pointer points to a segment of memory the size of an integer. So this is a very important thing. This is why pointers need to have data types associated with them. So a pointer contains a memory address, right? All of the memory addresses are the same size. But in order for C to actually go to that memory address that points to somewhere else in the memory and work with that data, it needs to know how big that data is. Like the most obvious example, consider the difference between a long integer and a character. A long integer, 64 bits. A character, 8 bits. There are 8 characters that can fit inside the amount of memory allocated to one long integer. So the question becomes, if I'm pointing to a character, basically it tells the compiler, find me 8, start at this address, get me 8 bits. Whereas if you're an integer a long int pointer, it's start at this address and get me 64 bits, right? The compiler, GCC, needs to know how many bits to find, right? And the data type of the pointer tells it how long, like how many bits to extract when we follow pointers around. So that's why you need a data type. There is such a thing as a void pointer, but a void pointer is a pointer that has no data type associated with it. In order to dereference that pointer, that is to say, in order to go to the memory cell that that pointer points to, you need to give it a data type using casting. So, you need to cast it as an integer pointer, for example. So, the star character may be applied to either the data type or the identifier itself. So, in this example, we've pointerized count pointer, and we have not put an asterisk on count. This asterisk only pointerizes count pointer in this example. However, if we were to apply it to the int, well, it's actually not what you would expect. Count pointer is still the only variable that would be pointerized. So, question: how would you write a character pointer? Very simply. Topic 6.c. It would be very simple. I gotta open that with gedit. There we go. So, include stdio.h int main. It would simply be char star pointer or char star pointer, like that. Either one would do. So then if you had a char x, say it contains the letter x, then pointer would be equal to the address of x. Actually, I'll make that a different thing. Let's make it z, so that it just looks different. So I would then print f a character, I believe that's C, new line, x, that's one way to do it. Another way to do it is to dereference the pointer with the star character again. And we can always view the actual pardon me. We can view the actual value of the pointer itself using %p. We don't have to dereference it in this case. So let's compile that up and see what we get. GCC topic 6. There we go. A.out. So you can see the pointer, like this is an actual location in my system's memory, and you can see both times we get the same character. Blessings to you too, Andrew. Thank you. So in general, only the first variable is pointerized. Yeah, in order to do multiple ones, you would have to do pointer1, pointer2, etc. That should be a comma. There. That's how you declare multiple pointers on one line. You don't need to declare multiple pointers on the same line. I think all the arrays in the assignment were initialized as pointers, right? I don't think I actually did anything differently because of them, so why couldn't the arrays just be any other variable? So we're going to get into the relationship between arrays and pointers. But we have to talk about pointers first. We have to work up a good working understanding of pointers. Then we'll talk about how pointers and arrays are actually the same thing. Well, arrays are pointers plus pointer arithmetic and allocation of memory that's more than just one memory cell. Right? So, in this case, we could declare count with the value 7, and we could declare the count pointer to point to count. This is, of course, the names themselves don't do this. You have to do it manually with the address of operator. Pointer facts. You can create a pointer out of any data type, including custom ones. Star means something different when you're not declaring a pointer. It's not part of the identifier. So this, you should think of star as being an operator. Since pointers are a more direct manipulation of memory, you can squeeze some efficiencies by squeezing in some pointer. You can squeeze out some efficiencies by squeezing in some pointers. So one of the reasons that C is considered a very fast language is because it is possible for you, the programmer, to optimize memory management in a way that's not possible in other languages. Because you have direct control over the manner in which C interacts with its memory, basically any other language, like, Python. So, yeah. Like, if you consider for a moment snake language, Parseltongue, the way that it handles memory management is fixed. It has a fixed heuristic, right? It does specific things in a specific order. You're not supposed to worry about it, and that's fine most of the time. But by converting a Python program to a C++ program, and C++, of course, being C++, you can actually get, like, a 5 times speed increase because you have direct manipulation over pointers. So are pointers like indexes? Pointers are indexes if the thing that you were indexing was the entirety of your system's memory. So yeah, that's actually not a terrible way to think about it. Pointers are indexes if you consider the entirety of your system's memory to be the array, which in a way it is. That's how computer memory is actually accessed. It's like it's one gigantic array, and the pointer is a particular index in it. Yeah. So stylistic points. To avoid the confusion on the previous slide, it's better to declare pointers and direct variables on separate lines. Putting some indication that a variable is a pointer in the identifier is a good way to be able to tell which variables are pointers later on. Am I on the low latency? I am on low latency. Good. Haha. So, like a lot of things in C, uninitialized pointers contain junk data. So, if I were to just declare a pointer, right? Pointer 2, for instance. Pointer 2 has nothing, it's not being assigned to anything, right? So pointer 2 will contain what exactly? Gotta recompile. It contains smelly garbage. Although that smelly garbage seems to be pretty close to the other stuff. Most consistently, actually. Quite consistently. It's like got a consistent offset. That's so cool. Yeah. So. So what does the star do again? A bit unclear on that. It does different things in different contexts. If it's inside of a declaration statement, it turns this thing into a pointer, right? Without the star, it's just an integer. With the star, it's a pointer. We're going to see what pointer dereferencing looks like in just a moment. So please just bear with me. Hopefully this will become more clear as we go on with it. So, pointers should be initialized to either 0, null, or a value that makes sense. Null is a symbolic constant which is defined in a number of header files such as stdio and standard defs.h. null is actually the same thing as 0, but it's preferred for stylistic reasons. So null pointers, that's like, null is like your uninitialized state for pointers. So you can check to see if a pointer is null before doing stuff with it, and that's usually a good idea. So we've done the nouns, now here come the verbs. So we now know how to store memory addresses, but what good is that if we have no memory addresses to store? To access the memory address of an element of, like, to access the address of a variable, you use the ampersand address of operator. It is a prefix operator. Applied to any identifier, it returns the physical memory address of that identifier. This actually includes pointers, so you can get the address of something that holds the address of something. And this is where we start to really see pointers, like, come alive, because we can have pointers to pointers to pointers to pointers to pointers to pointers. So you'll have seen me, so I'm doing that here, right? So I'm taking the address of x and I'm assigning it to the pointer, right? Very good. Again, just because you've named two things similarly, that doesn't actually establish any type of relationship between them. You have to actually physically perform this manual step of assigning the address of one to the other, because again, this is C and there are no free lunches. So graphically, we usually represent pointers with arrows, but sort of in terms of the actual representation in memory, you would have y being some designated location at a particular address, and when you assign y pointer, when you assign y pointer the memory address of y, you're taking that number and you're storing it. It's at some different location in the computer. The inverse operation of ampersand is pointer dereferencing. This is a little confusing, but it's also the star character. Also, the formatter for pointers is, again, %p. So to get at whatever you have referenced, you dereference it with the star character. So in our example here, when we print pointer 1, you see we get the memory address, right? We get the memory address here. When we dereference pointer 1 star, we get the actual value that's being stored there. So that's how it works. Any questions about that? That's like an important thing to get. Questions? So the memory location of x and pointer 1 is the same. So the memory location of x is stored in pointer 1. Pointer 1 has its own location in memory that's different from x. So, for example, if I were to print the address of pointer 1, right? You can see that the address at which pointer 1 is stored is in fact different, although not highly different, from the address at which x is stored. Can we go through the example one more time? Yes, let me answer the questions first. Why was it pointer is equal to address of x and not just pointer is equal to x? Well, because this is not a pointer, right? We are storing, like, the data type of pointer1 is a memory address, right? If we were to assign x to pointer1 like this, like if we would just remove that character, right? First of all, we get a warning. Assignment to char star from char makes pointer from integer without cast. So that's, you know, it's like, I don't know about this. And then, if you try to execute it, you get a segmentation fault. So you can, like, you can do it, but it's not advisable, right? So what gets stored in pointer1, if you just assign it x, is the ASCII value of the character z, right? If you were to then dereference that, you would be taking the binary representation of z, you would then assume that that is a location in memory that you have access to, which it is not. You would follow it to that point, and then your operating system would shut you down and say that memory doesn't belong to you, which is what that's what a seg fault is. It's your operating system saying, hey, you don't belong to that. That's not your memory. Get out of memory you don't belong to. So yeah, so the address, you do need to actually find the address of x rather than just x itself. Like, again, there's nothing, like, although C knows it's a pointer, because you've declared it as a pointer, it doesn't change any operations based on the fact that it's a pointer. Like, it doesn't automatically assume you want the memory address of x, even though that's a decent assumption. How did people learn programming before the internet? Manuals. People learned how to program from manuals. Can you point to pointers? Why, yes. Yes, you can. Absolutely, you can point to pointers. Is the memory address of a value the same if you ran it from two separate scripts, or is it unique? First of all, this is not scripting. This is not a scripting language. This is proper programming, so please adjust your nomenclature accordingly. But yeah, so if you see we have consecutive runs of the same program, you'll notice that the memory addresses are slightly different each time, right? This is because, you know, a different section of my RAM is being used to run this program every time I run the program. So yes, the pointers are going to change each time you run it. It's effectively unique, although there's nothing preventing you from having the same memory twice. It's just highly improbable given the space that the memory given the amount of space there is in memory, the idea that you would get the same two blocks of memory on consecutive runs of your program is pretty unlikely. You might be close, but you'll never hit it exactly. So if we consider the memory as an array, then the address of x is the index of x in the memory, and we assign it to the pointer. Yes! That's a good... Yeah, thanks, David. That's a good way to think about it. So yeah, if you think of your RAM as one gigantic array, the address of operator tells you the index at which this variable is sitting. Yes. Why do you use memory addresses for scanf? Because what scanf does is it plops whatever you enter in, it dumps it straight into a variable. It's a way of avoiding having to do an implicit assignment. Scanf, it is kind of an implicit assignment. Yeah, I don't know. Like a lot of these really old functions like scanf, they work like assuming you know pointers, because like if you had been a programmer who had started off programming in assembly language and then was learning C, you would have a very good grasp of these concepts, and like it would be natural to you to to provide a memory location at which to put that data. But in our modern context, it's like, well, can't you just give the variable name? Isn't that good enough? It's like, no, because the variable name means you're dereferencing the variable and getting a value. It confuses things. But yeah. From Emmanuel, where can I meet this guy? A good one. If we use the pointer dereferencing to call the value at the address the pointer is pointing at, does the pointer lose that memory address now, or could we call it again on the next line? Yeah, they're persistent. That is another way of phrasing that question, David, is, are pointers persistent? And the answer is yes. So notice that I'm dereferencing the pointer here to get at the value of C, right? I can do that as many times as I like. Yeah, so pointer dereferencing is not a destructive process. It doesn't destroy the memory address. All you're doing is you're following it. You're following it to some other point in memory. So I'm guessing the memory location selection for storing variable declarations is random, right? If that's the case, could previous memory in that space be deleted? So that kind of gets into operating system problems. So it's not random because nothing in a computer is truly random, A. So that, can't be random because of that alone. But B, it has to do with, like, the specific eccentricities of the, it has to do with the state of the operating system when you declare that, right? When you fire up your program, whatever the state of the operating system is, that's going to determine where in memory you are given a little chunk to run your program, right? So wherever that chunk is in memory, that's going to depend on the state of the operating system at the time you start up the program. So effectively random, right? It's like it's one of these cases where you have something that's like arbitrary but deterministic. So you can't rely on it being, in the same place every time. To us, it looks like randomness, but to the computer, it's not. It's kind of like a chaos theory thing. It's like anything that's sufficiently complicated looks random. That's kind of how the memory allocation looks to us, poor, insignificant humans. Could previous memory in that space be deleted? So the operating system will only ever give you memory that's not being used by something else, right? So you don't have to worry about when you declare a variable, it overwrites variables in some other program. You don't have to worry about that because, these were among the earliest problems that were solved by operating systems. Or even compilers. Like at a compiler level, you have to be sure that when you declare two variables, they're not the same memory cell. But yeah. So when you dereference a pointer, it doesn't lose where it was referencing to. Dereferencing kind of makes it sound misleading. Yeah, because it's like delete, yeah, it's kind of, that's just the nomenclature that is used, I didn't come up with the term. But if you were to come up with a better term for pointer dereferencing, I would say follow. Following a pointer is probably a better way to phrase it. What is the utility in a pointer? Why does not using a pointer confuse things? So we're going to get to it. We're going to get to what the applications of pointers are. But essentially, you know, it's kind of funny because, like, what are the applications of pointers? Well, do you use a computer? You know? It's like, pointers are such an important part of the substructure of programming that, like, it's kind of like asking, like, what's an if statement good for? It's like, well, I don't know, because it's used so much. I've never had to think about why it's, you know, you couldn't conceive of the idea of programming without an if statement. In the same way, you can't really conceive of programming without pointers. It's just all of the languages you've been using so far have been handling it for you because they're kind of difficult. So it's like all of these languages, like Snake language, all of these languages use pointers. Every single one of them. It's just, do they let you see them? Right? So if you wanted to write a new language, which is a thing people do want to do every once in a while, you need to know how to use pointers. But, yeah. Is it like asking, why do we need sleep? Yes. A bit like that, yeah. Yeah. When some data is deleted from a space, where does it go? Is the data in that space just reassigned to a different space on the system? Generally speaking, when you delete data, you're not overwriting it. Like, so, okay. We have a memory cell, right? Let's say we have variable x, or foo. Let's call it foo, because that's more traditional. So we have variable foo, right? Let's say that this gets deleted somehow. Let's say it's a local variable in a function, and the function terminates, right? That variable gets deleted. What actually happens, the actual physical memory that constitutes that variable is not overwritten. All that happens is that the reference is broken. So there's this this implicit assumption in computing, which is data without context is meaningless, right? So it's the it's the relationship between the memory cell and like when you have a program running, you have a table that keeps track of like what variable is what memory address, sort of. Well, that's not actually true. That's how the compiler thinks about things. Once you're actually executing your function, like variables and variable names, like the idea of a variable is not an idea that exists at the at the object code level, right? Variables don't exist inside of a compiled program. There's no such thing. There are memory addresses, right? All that's happening, this is what a variable is, all right? Cool facts about computers. Variables do not exist at the object code level. When the compiler encounters a variable, it has a little table, right? It has a little table that has a bunch of references, right? It replaces the variables for memory addresses, right? It's like, it's got spots. It's like, okay, memory address 1 goes here, memory address 2 goes, like, memory address 1 goes here, 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 and here. Memory address 2 goes here, here, there, there, and there. Memory address 3 goes here, there, and also here. When you run the computer, or when you run the program, the OS provides the object code with specific, like a specific amount of memory that it gets to operate with, right? Those memory cells, which the variables are, like, The memory cells which constitute the variables are pulled out of that memory that's given to you by the OS somehow through some mysterious process. Ask Linus Torvalds or ask Dennis Ritchie. And then, when the thing is actually run, it's like your object code doesn't contain the words foo and bar. It contains memory addresses. Everything is operations on memory addresses. Everything. It's a Turing machine. At the fundamental level, it's a Turing machine. It's memory addresses. Anything symbolic is something that's added by the compiler for your convenience. I don't know why I got angry about that. But yeah. Anyway. So yeah, like asking why are memory addresses useful? It's like asking why the keys on your keyboard are useful. It's like, well, I don't ever use tilde. Why do we have it there? It's like, because people use tilde, you know? Just because you're not using tilde doesn't mean tilde doesn't get used. So anyway. Pointer dereferencing. So dereferencing a pointer that points outside of your program's allocated memory space causes a fatal runtime error called a segmentation fault. So this is most common with null pointers, but it can also happen if you mess up your pointer arithmetic. So you've been spoiled by Python. Yes. You have been spoiled by all high-level languages. You use tilde for the CSGO console. There you go. Yeah. Yeah, welcome to C. Try not to drown in the sea. So, we actually had an example of a seg fault that happened right here, right? So, if the pointer isn't valid, right? If it's an invalid pointer, and you dereference it, what happens, that's the wrong... There we go. If you dereference an invalid pointer, you are following that pointer to memory that doesn't belong to you. The computer's solution to any program that tries to access memory that doesn't belong to it is to shut it down. This is very useful because memory that doesn't belong to you contains the data that's used by other processes, so if you had access to this data, you would be Mad Hacker with Mad Hacker skills. So this is what's called a segmentation fault. You're going to have segmentation faults. The interesting thing about a segmentation fault is it won't necessarily... Like, there's kind of two classes of segmentation faults. Sometimes your if your program contains the potential for a seg fault, there's like cases where it's pretty guaranteed that you would end up with a seg fault every time. So that's like if you were dereferencing a null pointer, that'll give you a seg fault pretty much every time. But if you have a pointer, like if you've messed up your pointer arithmetic somehow, like you're overstepping the bounds of an array or something like that, you might have the seg fault happen only every third time, right? So so when you're writing a program in C and you're doing pointer stuff, it's a good idea to run your program a few times to see if there are no seg faults, because they don't necessarily happen every time. Could you give the rights to overwrite said memory? Something like an overpowered run as an administrator. Generally speaking, I think the only thing that has access to that level of access is the kernel. So unless you are the kernel, I don't think that you'd be able to grant yourself that level of access. But then again, that's sort of... I'm still in the realm of normal user, you know? Like, when I'm talking to you about all of this stuff, I'm talking to you from the level of a normal user, right? I'm not talking from the level of like extreme privilege. This is like normal user level of privilege. Even super user doesn't have that kind of access. But yeah, because like the thing you could do if you had like access to all of the RAM, like untold destruction, you could wreak untold destruction. But yeah. Well, I guess that's time. So if there are any questions, please ask me questions. And if not, I'm going to go have some lunch. What am I going to have for lunch? Maybe some leftover lamb stew. We had a leg of lamb for Thanksgiving. We were originally going to have it for Easter. It's been in the freezer since Easter because basically like a week out from Easter, Felix was born, so that was like a whole ordeal. And, it's kind of one of those things. After having brought new life into the world, you're kind of just done for a couple of weeks. So we were kind of just done through Easter, so we never actually made like a special Easter meal. So we decided to have it for Thanksgiving instead, and the stew is still left over. So I'm gonna have some stew, probably. Either that or grilled cheese and tomato soup. If I print address of Y, then would I get the memory location in that last example right? Yeah. So yeah, so if you want to print, like, you can print the addresses directly. You don't have to store them in pointers first, right? So if you... or X. There we go. Because I don't have a Y here, right? So this is the fourth one. Fourth one should match the first one. Fourth one matches the first one. There we go. You can use the addresses directly. How is the parenting life? It's cool. It's very interesting. Small humans are fascinating creatures. It's like watching, like, when they're very, very small, they have, like, the, sort of, they're basically mechanical objects that sleep, eat, and poop. And as long as you can make sure that, they're sleeping, eating, and pooping correctly, and not, as long as you can keep them fed, sleeping for a good amount of time and clean, that's all you really need to know about them for, maybe the first month or two, depending on the kid, of course. Past that point, they start developing, various abilities. Felix is in an interesting phase right now because he's kind of, like, for a couple of weeks now, he's been, like, right on the edge of either developing the ability to crawl, developing the ability to crawl. Walking is a little bit, further down the line, but he's ahead of the curve on that one. But yeah, it's like once they're once they've like solidified a little bit, I guess that's the term I would use. Like they have to like when they're very very new, they're kind of fragile. Like you don't want to break the baby, right? But the older they get, the more robust their constitution becomes. So you can start, you know, um, you know, sort of pulling on them and stretching them out, and you know, hanging them upside down from their ankles, and freaking out their grandmother by doing so. But yeah, like he's kind of in the phase now where he's like working really hard on his physical development. Things like hand-eye coordination and being able to coordinate, like, once he figures out how to coordinate leg movement with arm movement and also be able to raise his belly off the ground, he's basically made it to crawling. And he's not quite to crawling yet, but he's really close. But yeah, and also, like, at this point, it's like visual intellectual stimulation. But at this level, it's like he's acquiring language skills, but like the main work that his brain is doing right now is just hooking his hands up. It's interesting. I've kind of been thinking about it kind of with a metaphor of like, it's like he's got the hardware, but like he just needs to connect the cables, so he's like connecting up his hands, he's like learning how to pick something up without having it fall out of his hands and stuff like that. How to pick things up with two hands if it's too big for one hand, or when something's too big for one hand. All of these types of skills that, like, certainly children and adults take completely for granted. It's like a baby has to learn from scratch all of these skills. It's very, very cool and interesting. So I highly recommend having children if you're interested in having an adventure. Yeah, only positive things. But anyway, I'm going to get off here. I'm going to get off the stream. So take her easy, folks, and we'll see you on Thursday.